Viscoelastic testing of polymers. The understanding of viscoelastic behavior of polymers requires that very careful experiments are conducted for a range of frequency or time and temperature. We studied a number of tests that could be performed. These tests are simple tensile or compression tests, creep test, stress relaxation test, recovery test, and the dynamic loading test. Each method has its own advantages and disadvantages. Therefore, a variety of tests may be necessary to really understand the polymers and use the data for a particular design. So here there are many precautions that we should observe during the experimental tests of viscoelastic materials. First one is sample conditioning for creep and recovery tests. Before conducting creep and recovery tests, the polymer sample should be conditioned by loading the specimen to the maximum load and temperature as to be formed in the actual test. Recovery should be performed for at least 10 times the loading period. This is to avoid long-term history effect and ensure complete recovery. As we know, any viscoelastic material like polymers have what is known as history effect, or it is also known as memory effect. That means the polymer has some memory of the previous loading cycles. The previously what happened to the material is somehow put in its memory and the molecules behave in that way. So the material is responding to previous loadings. So therefore it is important that we do sample conditioning before we conduct the test, and it is recommended that we should load the specimen to the maximum load at the given temperature. Whatever temperature we are using, we should maintain that temperature and the maximum load that we want to subject this material to. So we should apply the maximum load, and then we should conduct the recovery test. So we should apply the load for certain duration, and then we should subject it to recovery process for at least 10 times the loading period. So if we do this sample conditioning for several times until we are sure that this material does not have any history effect, then we can use this material for further creep or recovery tests. So by conducting this sample conditioning, the sample loses its long-term memory and now remembers the history only in the past few cycles. Also, the recovery is nearly complete after the loading period. Recovery period should be at least 10 times the loading period. So during the test, if we are conducting the recovery test, then it should be at least 10 times the loading period. Temperature control. Polymers and any kind of viscoelastic materials are very sensitive to temperature. So therefore, precise temperature control, especially in the vicinity of major relaxation region, is necessary. So a polymer will undergo various changes in its temperature cycle. So especially during those changes, for example, glass transition temperature or secondary transition temperature. So for these kind of temperature, it is very important that the temperature control is very precise during our experiment. Third is ambient environment must be controlled. As we know that polymers are affected by its ambient, for example, gaseous or humidity. The gaseous environment and the humidity should be controlled very precisely. For example, humidity has a strong influence on nylon. Similarly, many materials will be affected by the gaseous environment. For example, presence of hydrogen. Or if we are going to test a material for hydrogen application, then we must precisely control the environment, the kind of gas purity, and also the kind of pressure, gas pressure. We must maintain this during the test. Another point is, for large strain, load should be changed for the same applied stress. Change in cross-sectional area due to large strain can mean that the stress is changing too. Therefore, load should be gradually reduced as the cross-sectional area reduces in the same proportion for the same stress. So for example, if we are conducting a constant stress test, for example, creep test at a given fixed stress, then and if we are experiencing large strain, then we should know that the cross-sectional area is also changing as the material is getting more and more strained. So therefore, it is very important that we change the load so that we can maintain the stress constant. So as cross-sectional area is reducing because of extension, for example, if we are conducting a tensile test, as we are stretching the specimen, the cross-sectional area is reducing. Therefore, we should reduce the load as well so that stress can be maintained as constant. So this is very important. Another point is the loading rate immediately before measurement is to be controlled. So whatever measurement we are going to conduct, for example, creep tests or recovery tests or stress relaxation tests, the loading history, the loading just before the test starts is very, very important because the material is influenced by the loading rate. For example, here this is a stress relaxation test, stress as a function of time. If the specimen was given a fast loading, then we will experience this kind of trend. So for very fast loading, the stress will be higher and it will start at a higher load, and then there will be stress relaxation. For slow loading, we will experience this behavior. So starting stress will be low and then there will be stress relaxation. So the loading rate prior to the measurement has influenced the behavior, the stress relaxation behavior. This is for creep tests. So here we can see that strain has been plotted as a function of time. Very fast loading prior to the strain measurement can lead to this kind of instability. So this is because of the rate of load application prior to the measurement. So therefore, it is important that we understand and take care of the loading rate, because in most of the creep and stress relaxation discussion before, we have always used very idealized curves. But in reality, actually stress relaxation as well as creep are affected by the loading history prior to the measurement. So this is very important. Other important aspect is clamping stress should be considered in tensile tests. In tensile tests, we have to use a small specimen and we clamp in these areas. So in the top side and the bottom side, we clamp the specimen. So this clamping stress is very important because stresses in the clamps region will vary greatly from those in the bulk of the specimen. So whatever stress we see here will be different from the stress in the bulk of the specimen. So to avoid this issue, length should be at least 10 times the diameter of the sample. So this length should be large enough that it is at least 10 times the diameter of the specimen if it is a circular cross-section area. So it can be 10 times or more than 10 times to avoid the effect of clamping stress. Also, the extensometer or laser method should be used and strain should be measured away from the two ends. So these are the two ends of the specimen. So strain should be measured somewhere here, not at these ends. And for that we need to apply extensometer or we need to apply a laser method to measure the strain in this part of the specimen, only in the middle of the specimen, avoiding the clamping stress. In a stress relaxation measurement, load cell should be stiff in comparison to the specimen. This is to ensure that the specimen strain is maintained constant during the test. Any compliance in the load cell will lead to a change in the strain in the specimen. So it is very important that the load cell is very stiff in comparison to the specimen so that there is no change in the specimen dimension during the stress relaxation method, because in stress relaxation we maintain the strain in the specimen and we measure the change in the stress. Lastly, we will discuss this point. The creep test must be conducted over an extended period covering a specific application. So whatever application we are thinking about, for example, an application may be a continuous stress for a long time, or it can be an intermittent stress application. So based on the application, design application, we can decide about the period of test, because materials may behave differently for short term and for long term. Here is an example. polymer A and polymer B. We can see that polymer B has lower creep strain in the beginning, but after some time the creep overshoots. The rate of creep is very high. It accelerates after some, whereas for polymer A the creep rate continues to be in the same region, and after some time it is lower than the creep for polymer B. So a polymer may have a good short-term creep behavior, but its long-term creep behavior may not be very applicable. Also, the recovery process for short-term tests and for long-term tests may have different behavior because the polymers are inherently non-linear viscoelastic. Therefore, this non-linearity effect will come in, and therefore it is important that if we want to test the application of any polymer for a given time, we should conduct the test for the entire time rather than conduct only short-term tests. So these are the important points that we must consider during the experimentation involving any viscoelastic material, polymers or elastomers. Let me summarize what we discussed in this video. Sample conditioning is very important before conducting any viscoelastic test on a polymer specimen. The ambient temperature around the specimen must be precisely controlled, and the temperature should be maintained same as the service temperature in actual application. The ambient environment such as humidity and gases present should be controlled, and it should be same as the actual application environment. For tests involving large strain such as long-term creep test in the specimen, load should be changed such that the stress is maintained constant throughout. Loading rate before the test measurement starts for creep and stress relaxation should be controlled and simulated with the actual application. In order to avoid the effects of clamping stress in tensile tests, the sample length should be at least 10 times or more than the diameter or width of the specimen. Strains should be measured in the middle zone of the specimen, avoiding the two ends of the specimen where it has been clamped. Extensometer or laser methods should be used to measure the strain. Thanks for watching. If you have any question or comments, please write them below in the comment section.